Hello and welcome to Module 4 of the Cōnsilium Aquīs Sulis course in GB Mainline Signalling, Part 1. In this course we're going to look at points, signals, routes, overlaps and route classes. Points are a movable section of tracks that allow trains to be guided from one track to another, and they're moved and locked in position by the signalling system. They can operate in isolation to allow trains to take different paths over a junction, or in pairs known as crossovers to allow trains to move between adjacent tracks. In rare occasions they can also operate in larger groups. The term signal was originally quite straightforward. It was a mechanical electrical piece of equipment on the track that communicated movement authorities to the driver. But as we move into the information age with computer-based signalling and cab signalling, definition became a little bit more ambiguous. It could be the device that communicates the movement authority, or it could be a physical marker at the end of the movement authority, or it could simply be an association of interlocking states or states within other parts of the signalling system that conveniently allocated the name signal. Mechanical semaphore and coloured light signals are the original meaning of the word signal, and they communicate movement authorities to drivers from the trackside infrastructure. They also indicate the path of those movement authorities and, to a limited extent, their lengths. But of course, in cab signalling systems, signals in that traditional sense of the word are no longer required because the movement authorities are presented in the driver's cab. However, there is another important role that these signals perform, which is to physically mark the end of a movement authority, which can be very useful if you want to stop accurately at the end of the movement authority, or authorise a train procedurally to pass through a route when the signalling system is not functioning. Hence, cab signalling have often found it a need to fulfil this role through various pieces of signage or stop markers that delineate where movement authorities start and end on their physical layout. And irrespective of which technology we're using to communicate movement authorities, the term signal is also frequently used to describe states within computer-based interlockings and other signalling technologies. For example, the points between which routes are start and end, or from which movement authorities are issued from and to, or associated with locking of infrastructure related to the issuing of movement authorities or after movement authorities have been issued previously. Routes are defined paths over a track layout from one signal or cab signalling equivalent to another signal or cab signalling equivalent, and they are set either by signals or by some form of automated control system. At the end of many routes we have something called an overlap, which is a section of track beyond the end of the route which overlaps with the subsequent route or section of track, but is reserved for trains entering the route, and it can serve a number of purposes. It can simply mitigate the risk of driver misjudgment when stopping at a red signal at the end of the route, or it can provide a safe overrun distance for trains when there's some form of train stop is provided at the red signal. So if a train passes a red signal, the train stop can apply the brakes and the overlap provides a distance to come to a standstill. Or similarly, with more sophisticated comprehensive automatic train protection systems, it can allow the train protection to provide a very conservative level of supervision to the end of the overlap, while still allowing trains to closely approach the red signals at the end of their legitimate movement authority. Various classes of routes are defined, which have various types of overlap. The most basic class is the main class route, which is used to authorise trains to proceed at the maximum permitted speed over a section of track, and with the exception of main routes up to buffer stops, all main routes have overlaps. However, sometimes it's not possible or desirable to provide an overlap of the minimum required length, for which we have Warner class routes, which have a restricted overlap, a shorter overlap. And the main difference between a main route and a Warner route is that trains entering a Warner route are slowed down before being permitted to do so, to mitigate the risk of having a shorter overlap. But this in itself requires some careful design, because slowing trains down could potentially encourage them to accelerate at exactly the point where you don't want them to, actually approaching the shorter overlap. Further class of route is known as a calling on class route, which is used to authorise trains to enter a section of track occupied by another train, a permissive move. Why might you want to do this? Well, maybe to couple to another train in a platform, or simply to share a platform with another service. And because trains are expected to encounter another train before reaching the exit signal for a calling on route, they have no overlap. And because of the risk involved, trains are only authorised to enter calling on routes when they are nearly to standstill, so going very slowly. Shunt class routes are used for non-passenger trains and can be either non-permissive, in which case they do have an overlap, or permissive, in which case they do not. They can be used over signal infrastructure as well as for entering depots and sidings that have no signalling. And finally, proceed on site authority. Poser class routes authorise trains to move when a failure prevents authorisation being given for a normal route, so they have very limited sets of controls. As with calling on routes, they have no overlap, and trains are only authorised to enter them when they are nearly at a standstill, owing to the risk involved. So we started this module by looking at points, the devices that are moved and locked in position by the signalling system, either individually or in pairs as crossovers, or occasionally in larger groups. We look at some of the ambiguity in terms of signals, both in terms of its original meaning as the physical semaphore or coloured light that communicates movement authorities to the drivers, the need to fulfil the role of physically marking the start and end of a movement authority, even a cab signalling system, and the use of the term to refer to logical states within an interlocking or other electronic signalling equipment. We looked at route as a defined path over a track layout from one signal or cab signalling equivalent to another, and the overlap at the section of track beyond the route, overlapping a subsequent route, those routes for trains in that route. Finally, we looked at different classes of routes and the overlaps associated with them. So thank you for your attention. In the next couple of modules, we're going to look at some fundamental areas of interlocking logic, those being the locking level and the aspect level. So please join me then. Thank you.